Alrighty, everybody, we just got our okay to start our planetarium show, so I'm going to put away our space trivia questions because now, folks, we're heading into the unknown. And welcome, everybody, to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person. I'm standing right behind you at the very top of the planetarium. Hey, good afternoon, everybody. Good to see you. But don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. Everything that you see in purple is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for our projector system, it's hidden just below that purple glow all throughout the room. And folks, I'm really happy to have you today because we're about to do my favorite show, hands down. This one's called Tour of the Universe. This show is completely live, so you're going to be hearing my voice for the next 30 minutes. And we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a forewarning, we're pretty small in the grand scheme of things, so just a heads up. And before we get started with the show, I do have to go over some quick house rules just so that we're all on the same page and have a good time. First off, there's no food or drinks allowed in. If you manage to bring any snacks, make sure those are put away till the end. We want to keep this place nice and clean. Also, if you happen to have any cell phones, smartwatches, anything that's really bright, now's a good time to put those devices away. These could be very distracting and takes away from the planetarium show. And if you need to leave early, the exits are always going to be at the very top of the planetarium, so always make your way up the stairs to exit. If the staircase is too steep for you to climb, don't worry, just remain seated. Once the show's over, we'll have a staff member escort you to a lower exit so that you don't have to climb those steep stairs, so just stay seated for a bit longer once it ends. And last but not least, folks, this show can be quite immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, well, there's a really quick and easy trick to ground yourself. All you have to do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling all the way to the edge of the observable universe. And also really quickly, I just want to do a quick shout out to a special friend, someone who always comes and visits our planetarium show, someone that goes by the name of Kate. So they're back, they're visiting our show. So big shout out to Kate. Thanks for being back. But with that being said, it looks like we're ready to go. So let's get started. So sit back, relax, and let's begin our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to the Earth. We can see the curvature of our Earth just down below, some city lights down below as well. But we're going to start off just a little bit above that, here at this really amazing human feat called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what's the International Space Station? I always hear about it in the news and articles, but I don't really know what it is. Could you explain it for us? Well, of course, folks, the International Space Station is a research facility. It's a laboratory that orbits all around our planet Earth. And they conduct so many different types of experiments up here, a little bit further away from the planet with less gravitational influence. Some of the things they'll conduct up here are like what happens when you try to grow plants in space, which way do the roots grow with less gravity? Another one that they tried out is what happens when you try to spark a match in space? Does that act the same with less gravity? Does it act different? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for a year. After that year, they compare and contrast the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower, but not only that, you also lose a lot of muscle because you don't have as much gravity working down on your muscles all the time while you're up here. So if you plan to live in space for a very long period of time, remember to exercise daily. And also, the International Space Station looks really big here in our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, that's also okay. You can also use the entire museum that we're sitting in. That's roughly how large it is. And what's really incredible is that the International Space Station is traveling really fast. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes. And it experiences 16 sunrises and 16 sunsets a day. Whew, How romantic. Also, this looks really far away from our planet Earth. But the International Space Station isn't too far per se. It's only about 250 miles above the surface of our world. 250 miles for us Californians, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. So, not too bad. But to tell you the truth, folks, this is as far as we put humans into space nowadays, only 250 miles above the surface of our world. The reason why is because going into space is very expensive. You got to build yourself a rocket ship, buy yourself one, or pay for a ride, and that's quite expensive. And then once you acquire that, you need to acquire all the rocket fuel. You got to be able to escape the Earth's gravity. And once you acquire all that rocket fuel, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space. So the bill gets quite expensive quite rapidly. But folks, the International Space Station is just the first stop on our tour of the universe. So now we're going to see it start to slowly fade away down to the city lights down below. And before we lose track of the International Space Station, I want to add a nice little orbital path so we can see it as it starts to slowly disappear. Alrighty, folks. Now we've zoomed all the way out and we're now able to see our entire planet Earth. And I want to let you know that the space program that we're using here is something that you can go home and download if you want to fly through space just like how I'm doing. The space program that we're using is called OpenSpace. So if you go to www.openspaceproject.com, you can come across the link where you can download this. And what's really fascinating is that OpenSpace is an open source software. That means anybody can add to it. So if you like making spacecraft models, you can add into the software. And also, what's really fascinating is that this isn't finished. They're still working on it. So it's in its beta phase. And also, this uses a lot of processing power. It pulls information from satellites. So if you have an older computer, you may not want to download it, but if you got something new that runs and processes information really fast, then give it a try. It's a whole lot of fun. So in here, we're using OpenSpace. But now that we got a sense of what we're using, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before. That was between 1969 and 1972. Thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, the last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years thanks to NASA's new space mission in the works called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars. But before we send humans deep into our solar system, we need to figure out exactly how we're going to be able to live out here in space. So the moon is the perfect stepping stone to figuring out the logistics of how we'll be doing that. And what's really fascinating is that they're going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years. So we're able to conduct much more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there. And that's going to be very helpful because we can melt that ice, pass electricity through it, separate the hydrogen and the oxygen, and both that stuff's really valuable when you're far away from home. So look out for any news about Artemis in the coming years. We humans should be heading back to the moon relatively soon. And folks, when you look up at the moon here from planet Earth, sometimes it feels incredibly close. It feels like you can reach out your arms and touch it. But the moon is incredibly far away. It's about 240,000 miles away from our planet Earth. 240,000 miles. That's a good distance away. Now, some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on now, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye-bye, moon. Aw, so cute. And now, folks, just like how we saw with the International Space Station before, we're going to see the moon start to slowly fade away. And just like before, I want to add some nice planet shells so we can keep track of it, because again, space is incredibly large. And now, folks, we're going to see the moon and the Earth in their orbits as they start to slowly fade away. And on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace showing us the most accurate images and information available to us. And now the nearest star to us, the sun, should be coming into view. So here comes the sun. Do-do-do-do-do. And folks, the sun is also incredibly far away from our planet. It's about 93 million miles. Whew, 93 million miles. I do not want to drive that. But in order for sunlight to travel that 93 million miles, it doesn't take sunlight too far to get from Earth to the sun to the Earth. It only takes sunlight about 8.5 minutes at the speed of light to cross that 93 million miles. And this is a really good concept to keep in mind because light takes a while to travel through space. So it takes 8.5 minutes to get to Earth. And that works for really far away objects in space as well. For example, let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So when you look at really far away objects in space, it's like looking back in time in a sense, which is really cool. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what we have. Right in the middle, we have our star, the sun, the biggest thing. The closest planet to the sun, we have Mercury. Then we have Venus, and then Earth, that's us, and then Mars, the red planet. And then beyond Mars, we have something called the main asteroid belts. And this is what it would look like if we were to highlight all those asteroids. There's roughly about 1 million asteroids in this region, give or take. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We have Jupiter, the largest of them all. Saturn, famous for its rings. Then we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can add everyone's end favorite lovable dwarf planet, Pluto. So here comes the orbit of Pluto on screen, just on the bottom right-hand side. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. Yeah, that's a lot of stuff. Who knew? And it turns out the Kuiper Belt is a second asteroid belt past the orbit of Neptune. What you're mostly going to find out here are icy asteroids and short period comets that don't stray too far away from the sun. And what's really fascinating is that we came across the Kuiper Belt in 2006. Our telescopes and technology greatly improved, so we're able to see much smaller objects much further away. And in 2006, they came across more than 400 objects in the Kuiper Belt region. Some of this stuff was bigger than Pluto. So we couldn't call all these things planets. There was just way too many of them. So all the astronomers on planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And they came up with 3 different criterias. And folks, that was the day in 2006 that Pluto went from being a planet to a dwarf planet. And I know a lot of people still have hard feelings about that. I still kind of do. But that's the really cool thing about science, because as our technology improves, we're able to make better observations. So science is constantly updating and changing, and I just love that about it. But for now, I'm going to be putting away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding on screen some of many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. You can see that interaction just by Pluto's orbit. And all of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to get all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours to get all the way out here. Not too bad. But folks, it's time for us to leave our planetary scale behind, because now we're heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us roughly about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. Hey, look at that. Alpha Centauri just flew by right in front of us. That's a first. So again, we're right in the middle of our screen. Alpha Centauri is the star moving right in front of us on the left-hand side. And again, 4 years at the speed of light just to reach the next star system to us, folks. But that doesn't really put into perspective how long it would take us humans to travel that distance. Well, if you're getting a rocket ship today, made your way over to Alpha Centauri, it's going to take you roughly about 8,500 years to make that journey. Whew, and that's just a one-way trip. But let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. So again, we're now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later, the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year. So is anybody out there listening? And now, folks, I'm going to be adding many markers onto the screen. These markers indicate the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed, created in laboratories, and then they got to be launched into space and then conduct science. So we've got a little while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. And of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. But for now, folks, I'm going to be putting away our exoplanet markers, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. And now, folks, we're looking down on our Milky Way galaxy. This is the galaxy we live in. And I've got to ask, can anybody see their house from here? Just kidding. And folks, our Milky Way is incredibly large. If you wanted to cross it from one side to the other, it's going to take you roughly about 130,000 years at the speed of light. And the Milky Way is so huge, we estimate that there's at least 300 billion stars in the galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, well, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave the Milky Way, I want to show you what it looks like from the side. You're going to notice that we live in a big flat spiral disk. Kind of looks like a big pancake or a frisbee in space. And this is important because when scientists and astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking to the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north to the top or galactically south through the bottom. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group, which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda galaxy. Only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue expanding out, folks, you're now going to realize that galaxies are not evenly distributed throughout space, where there's one galaxy in a nice little neat line and another one over there. Instead, galaxies like to group together in large groups and clusters, or they create voids where there's very few galaxies or no galaxies at all. So we can see some nice galaxy clustering towards the center of our screen. We can see very few galaxies or no galaxies towards the top left. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, this picture that we're now looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing researcher by the name of Dr. Brent Tolley, who worked at the University of Hawaii, who compiled this amazing map over decades of time with the help of other astronomers working aside him. So big shout out to Dr. Brent Tolley. But now we have automated systems that are mapping even the most distant galaxies. So folks, we're now about to see the large-scale structure of the universe. And remember, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Look at all those galaxies. There's so many. And as we start to spin around, you're now going to realize that the large-scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a big flat spiral disk of the Milky Way galaxy? Well, if we don't line up our Milky Way, it would line up just down the middle, like so, up and down. And again, we like to point our telescopes galactically north and galactically south. But astronomers still want to make sure that there's galaxies through the plane of the Milky Way, so we have this purple survey of them. You'll notice that we're still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to fill in all these areas that haven't been mapped out yet, so it's just a matter of time. Ooh, and speaking of time, we're almost out of time. So let's continue pressing on, because now we're going to be encountering these really distant, faraway objects known as the quasars. And the quasars are going to be represented by orange dots on either side of the large-scale structure of the universe. Quasars are short for quasi-stellar radio sources, and these blazing objects are all billions of light years away. And now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the edge of the observable universe. What we're looking at is something called the cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And this is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, it's a temperature density image where the light echoes of the Big Bang are color coded with the lighter areas corresponding to the hottest, least dense regions, and the dark areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these tiny differences eventually gave rise to a large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we traveled as far back as the law of physics can physically allow us to go. So we only have one direction left to go, back home towards planet Earth. So let's find a nice entry point to all these quasars and galaxies. And this looks like a good spot. And let's make a return trip back to planet Earth, everybody. All right, everybody, we're across an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope. And there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we made our way back into our Milky Way galaxy. We just headed straight through that radiosphere, and now we're making our way back to our star system, our solar system, our little neighborhood in the vastness of space. And now we're about to pass those spacecrafts we sent out in the 1970s to explore our solar system, past the orbit of the Kuiper Belt and Pluto, and making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, love, ever learned about in history all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank you so much for stopping by and watching it with us today. I hope you did enjoy it. But hey, look at that. We made it back home to planet Earth just in time for dinner time. And that's all the time that we have for today. And I want to thank you again for stopping by, and I hope you get home safely. Have a good day, everybody.